Multi-area OSPF in all its glory. You know what's something funny? This picture, this actual graphic, matter of fact, the GNS3 topology, I'm about to use this guy right here. I actually pulled straight out of my CCNP series. Cisco's revised CCNA and added so much. Like I'm just pulling content from CCNP. Now, maybe by the time you hear this, this will be old news and the CCNP will be revised and there will be a lot more in there. But whew, as it stands, it's just a lot of information in the Cisco CCNA. So I totally get it. A lot of you, it's been a while since you saw OSPF in a single area in ICND1, so I plan on doing a little review and configuring single area OSPF in Area 0, the backbone. Then we'll tack on the new stuff with Area 10 and Area 20. I'm going to start off here with router 1. You can see over here in area 0. It's going to be connected to router 2 and 3 via a switch. It's still 172.30.00. Let's just get ourselves familiar by doing a show IP interface brief. Right, there we go. So 172.30.0.1 is router 1, just like the graphic implies right there. So in order to set up OSPF here, again, single area mode, it's pretty straightforward. I'm going to go into global config and do router OSPF followed by a number, which is the process ID. It can be any number that you want. Most people just make it 1. Is it possible to run multiple OSPF processes on a router? Yes, you can. Does anyone do that? No, they do not. Well, not normally done in the real world. So router OSPF 1, I'm going to now, let's set a router ID. Router ID 1111. Remember in the neighbor relationship discussion, we said that'll be the name of the router. You want to set that before the neighbor relationships form, because if you do it afterwards, it says, oh, sorry, you have to either reboot the router or clear the OSPF process. That's probably what you want to do there. A little less devastating. To reset the router ID. Once it picks its name, it stays that way until the router reboots. Okay. Now I'm going to type in my network commands. I'm going to type in network, and then what networks I want to run OSPF on. Cisco best practice says to go like this. Exactly like that. So what did I do? I went in and did 172.30.0.1. That's the IP address of the interface, and I said 0000 as the wildcard mask, which says enable OSPF exactly on that interface. Now I could have been lazy and gone 172. Hand in the wrong place. 172.30.0.0.0.255.25. I could have done something like that. I could have even done this. I could have said, you know what? I want to turn on OSPF everywhere. 0.0.0.0.255.255.255.255. You could do that. But the more broad you get, the more chance of accidentally adding something to the wrong, actually adding a wrong network in there becomes more likely. So now I'm running OSPF on that single interface. Good. I'm trying to think, is there anything else? No, I mean, it's really easy to turn on OSPF in a single area. So let's bring up router 2, which is sitting right there on the left-hand side. So I'm going to do privilege mode, global config. Let's just do a show IP interface brief, just so I can get oriented again. Okay, good. This is looking right just based on the diagram. It's the .2. So I'm going to go in and go router OSPF 1. Router ID 2.2.2.2. Now, okay, interesting fact. Now, we talked about the router ID in the concepts and neighbors forming, things like that. This doesn't have to be a real IP address. Some people... okay, I'll explain it now. Some people will actually create a loopback interface, and they'll give it the same IP address as the router ID, and then they'll actually send that loopback interface into the routing advertisement. So I'll actually do that. I'll show you how that's done, and that allows you to then ping the routers by router ID, because as it stands right now, I can't ping 1111 because the router doesn't know about it. It's just a router. It's a make-believe IP address from its perspective. So let me show you this. I'll exit back out here before I do anything more. I'll do interface loopback 0. Just again, you can have 2 billion loopback interfaces. They're just make-believe interfaces. See, it just magically came up right there. So interface loopback 0. I'll give it IP address 2222 with a subnet mask of 255.255. 255.255. Now, that may be the first time you've seen a subnet mask like that. That's just saying exactly that IP address is assigned to loopback 0. I'm not claiming to have the entire 2.2.2 subnet or anything like that. Just that one IP address is what I've got. Now I can actually ping that guy via that IP address. So I could ping the router and I can send that into OSPF so all the other routers know about that. And we'll do that, right? Okay, so let's go back in. Router OSPF 2. Oh, wait, what am I doing? Thinking 2222. No. Yes, OSPF 1. Okay, so I've got the router ID set so far. You following? Hopefully. Network 172.30.0.2. Again, using Cisco back. You know what? Let's get lazy. Let's go beyond. No, actually, no. I can't get lazy. What am I thinking? Because notice this network 172.30.10.0 is going to be in a totally different area, so I can't just lump them both together in area 0, right? So I'm going to come over here and let's do 172.30. We'll go back to Cisco. Cisco best price 0.2.0.0.0.0 area 0, right? Then let's also add in network 2.2.2.2.0.0.0.0 area 0. What did I do? I'm now advertising this loopback into the OSPF process. Now you notice, you probably are like, ooh, look at that, because I was. And when I saw this, it's like, oh, neighbor just came up. It went from, remember the neighbor relationship, from loading to full. That's the neighbor states that we go through. Okay, so what I'm expecting now, let's exit back down here. I'm going to do a show IP route. Let's just start there. Well, what's there to learn? What does router 1 know about that I don't already know about? Nothing. They're both connected to the same network. So router 1 is a very non-satisfying source for router 2 right now. But let's go over to router 1. I bet you it's seeing something. Let's do a show IP route. It should be seeing that 2222 interface. Yep, see it right there? It learned about router 2's router ID, which we made a loopback interface. We made it real and advertised it via OSPF. So let's do a ping 2222. You want to do the same for router 1? You want to make its well, hang on, let's do this. Show IP OSPF neighbor, right? So I can see what neighbors I have. I can see that this neighbor ID, it says you have a neighbor, router 1. It is actually 2222. They are a state of full. They're a full neighbor. And as a matter of fact, router 2 is so valuable because he is a backup designated router. We scratch your head and go, what was that? Remember we talked about in the previous nugget where I was talking about the concepts that the routers will form multiple relationships on a LAN, but they all back off and they elect that DR and BDR. Do you remember? If not, you might go back because it's not enough time to review it all. So router 1 is like, hey, I see router 2 is the backup designated router. So what's that mean about router 1? Just out of curiosity. What do you think? Well, router 1's looking out at its neighbor, and he sees a backup designated router. So I'd say there's a pretty good shot that that router 1 is actually the designated router. So I'm hopping over here to router 2. Check this out. Show IP OSPF neighbors, and let's see from router 2's perspective. Who is router 1? Look at that. So router 1 has been elected the designated router on the subnet. It's a full neighbor. They went through all those neighbor states, and it's a designated router. Sweet. Okay, so like I was saying, I want to do the same thing on router 1. Let's do interface loopback 0, IP address 1.1.1.1.0.0.0.0. Oh, wait a sec. I'm thinking of network commands. 2525. There we go. So I've now assigned that individual IP address. So I've now assigned the router ID of router 1 as a quasi-real interface, right? So that it's actually tangible. I can ping it. And now I can go under router OSPF 1 and do network 1.1.1.0.0.0.0 area 0. Bam. And now router 2, let's do a show IP route. So before, notice right here, he wasn't seeing anything useful from router 1. But now when I do a show IP route, shazam, we've got 1111 showing up there as an OSPF neighbor or OSPF route. Now I can ping him. So now when I do a show IP OSPF neighbor, I can see, hey, there's the neighbor, and they're real. I can actually ping them. Some people do that. And now keep in mind, I'm not saying you have to do that. I'm just saying some people do that because it's kind of cool. When you see somebody in the neighbor table, you can just say, oh, you know what? I actually want to telnet to that guy. Who is that guy? Well, when you configure your routers, right? And you actually set a telnet password, a VTY password, right? But then you can actually do that. You can just look at the neighbor ID and go there and find out who that actually is. Okay. Router 3. Let's hop down there, right? A little faster this time. We are reviewing. This is all review of single area OSPF. So I'll get into... on that note, I'm going to pause. Well, that nice little 60-second delay gave me enough time to wipe off the whiteboard and clear the screen. So I need to do that. No IP domain dash lookup command. That's if you mistype anything from privilege mode, it thinks you're trying to telnet to a device named, in my case, NE. So it's sitting there broadcasting, trying to resolve it. You don't want that to happen. So router 3. Now let's go into show IP interface brief. IP interface brief. There we go. So I see the two interfaces there. I'm going to go into router OSPF 1, and let's do, oh, actually, let's not forget this. Interface loopback 0. I'll do IP address 3333. 255.255.255. I'm just going to do this for the routers in area 0 because it's kind of fun. Router OSPF 1, I'll do network. Well, before I do that, I'll do hardcode the router ID 3333. And then we'll do network 172.30.0.3. Right? Now we have just reviewed that little section there was reviewing configuring single area OSPF. So now we've formed two neighbors from router 3's perspective. Let's do a show IP OSPF neighbor. And I can see from router 3's perspective, I see router 1 and router 2. He's the DR, he's the BDR. Now, there's a question. What do you think that makes router 3? If you got the DR and the BDR, what is router 3? Just a guy. If we go to router 2, notice router 3 has come up. I'll do a show IP OSPF neighbor from router 2's perspective. And you see router 3 right there. It's a full relationship, but it's a druther. It just means DR other. It's something other than the DR and the BDR. Kind of an interesting term that it uses. So now we've got single area OSPF configured. Now let's get into the new stuff, right? How do I make this an area border router and now have the ability to route between multiple areas, thus giving me the ability, not the automatic capability, but the ability to summarize routes going between these areas and optimize my routing table. Okay, so ICND1 versus ICND2. You ready for this? This is the one command to do it. Now, there's no command that I can type in there to say you are an ABR. I simply go into the router OSPF. I'm on router 3 right now. I'm going to type in network 172.30.20.0. So I'm turning on OSPF for this network right here, right? This guy. So 20 is 0, 0.255. And then I'm going to say area 20. Oh, we have now configured an ABR. Seriously, that's it. That's all there is to it. Like ABR-ness is done. You are an ABR. So that's why when I started looking at exam objectives for the ICND2, I thought, Cisco, you're crazy. There's no reason to do a multi-area OSPF environment without also adding in summarization, which again, I'm hoping by the time you hear this, they will have added it in because that's what makes multi-area OSPF even worth it. So I'm going to go in here and let me just show you the view from the ABR's perspective. Show IP route. So I'm going to type that in, and nothing. There's nothing special. Why? Well, because router 3, it's like a person with two really long arms. It's got one long arm in area 0 over here, and it's got one long arm in area 20 over here. Okay, so from its perspective, it's in both areas. It doesn't see anything special, but let's look at router 1. I'm going to hop on over to router 1 and do a show IP route up there. Ah, look at this. Look at this. It sees 172.30.20.0. It should stick out to you. See O, it's from OSPF and IA. What's that? Hang on, let's go up. IA. OSPF inter area, not inter. So it's outside of router 1. So now it's starting to see these things from outside its area. Okay, let's do router 4. So I'm going to go into router 4. Just booted it up, and nothing special about this guy. Show IP interface brief. And you can see that he's got an interface sitting here, 00, that's on that same network as router 3. But I also added, just for fun, four loopback interfaces, 10.20.0.1, 1.1, 2.1, 3.1. Why? Because I wanted to have more networks to play with, because I want to go beyond the current CCNA objectives and show you summarization. I know, don't worry, it's really easy. Show IP, okay, what am I doing? Router OSPF 1. Let's do router ID 4.4.4.4.4. I'm not going to actually create an interface for it, so it'll be there. It'll identify itself as that, but I won't be able to ping it, or I won't be able to telnet to it. So I'm going to type in network 172.30.20.4, area 20, and network 10.20. Let's go 00. Let's be lazy. 00.255.255. So throw in all 10.20 networks is what I'm saying. Area 20, right? So now I'm adding all of those guys into the mix to router 4. Okay, so now let's go to router 1 now. Yeah. Now we've got all of these routes. Now we're starting to feel a little cluttered. You feel cluttered? I feel cluttered. To where my routing table is getting a little saturated with some routes from outside. And so, again, the goal, the thing I really want you to see is doing an ABR by itself doesn't do anything. Never would you implement a multi-area OSPF environment without doing some form of summarization, because that's the whole reason you have a multi-area OSPF environment, right? So let's bring in the rest of this and be good to see a little redundant configuration. Let's go over to router 2 and router 5, right? Get them going the rest of the way. So, whoa, router 2, whoa. Don't you love Windows 7? Wiggle the screen and it all goes away. There we go. So router 2, I'm going to go in and let's do a quick show IP protocols. I'm going to get some other show commands going here. And you can see that I'm routing for networks 2.2.2.2, so this guy right here, and 172.30.0.2, well, this guy. So loopback and then area. So there's nothing in area 10 configured yet, but it does see all these different sources running throughout the network. So I'm going to go into global. Let's go into router OSPF 1. And by the way, my brain catches up to my mouth sometimes. Routing information source. That just means, who am I hearing information from? So it's identifying all the routers that have been configured so far. So I'm going to router OSPF 1, and I'm going to do network 172.30.10.2, right, which is this interface right here. I'm going to say 10.2.0.0.0 area 10. Okay. So I'm now including that guy in there, and let's go over and not forget about our friend router 5. Whoa. There we go. Router 5, show IP protocols. Does he even have OSPF yet? No. So we'll go into router OSPF. We'll do 1 router ID. I'm flying through this because I'm assuming you've seen this now 5 times, so you should be starting to feel a little warm and fuzzy about it. So 172.30.10.5. So I'm enabling OSPF for that network area 10. Okay, but I also, just for fun, threw a bunch of loopback interfaces on this guy too. See all these 10.10.10 networks? Or wait a sec, 10.10, I got a little carried away. So router, wait a sec, network 10.10.0.0, 0.0.255.255, area 10. Enter. Good. Okay, so now router 5 should be, so now we should really be feeling the clutter. Right? So I'm going to go back to router 1, do a show IP route, and now we see, right, yeah, you feel it, it's like, Now, okay, if real world, is a routing table this big a problem? No, it's not. Routing table can be hundreds, thousands and thousands of routes can be inside of here, but the principle is the same. We want to optimize. Bing, 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 insert CCNA bonus material. Right? Because what I'm about to tell you is not currently on the CCNA, but I absolutely believe it should be, and I absolutely believe Cisco will put it on there if it's not on there already. Okay, so what I'm going to show you is how we can do the whole reason we break into multi-area OSPF, which is summarization. Now, pop question, pop quiz, what routers can you do summarization on? As I'm pointing at it, area border routers, and remember the other one, autonomous system boundary routers. That is, routers that are connected to networks outside your system. Like router 1 kind of looks like one to me. I'm just eyeing it. He looks kind of funny because he's hanging over the edge there. I'm like, okay, he's kind of hanging out of the OSPF area. So I'm actually I'm smiling because I'm going to include this. I'm going to configure that guy as an ASBR. I'll show you how to do it. So. Okay, let's go for router 2. I'm going to optimize this network, and the way that I'm going to do it is by using something called area range. So I'm bringing up router 2 right here, and I'm going to do, so again, the way the command works, I'm going to say area and whatever area I want to summarize. So I want to summarize the routes from area 10, right? So I'm going to say area 10 range, and then I'm going to put in my summary route right there. Now, I'm going to do some really lazy summarization. It's going to be ugly, but you'll get the concept, and it's a lot easier to understand if I am lazy. So I'm going to do on router 2, I'll do a show IP route. And I can see all these 10, 10, 10 networks right here, all these, right? So I'm taking all these 4 networks from here, all these 10, 10 networks, and I'm sending them straight over to area 0 without summarization. I want to change that. So what's an easy way of summarizing those? I'm just going to say 10.10.0.0 well, I'll say /16 or class B subnet mask 255.255.0.0. So as soon as I type this in, and you're going to see it, it's going to start saying, okay, I'm going to identify anything that matches this area 10 range command and suppress it. As in, I'm no longer going to advertise all these more specific networks right here. I'm going to suppress it and replace it with this summarization. Watch how it works. I'm going to go on router 2. Area 10, hit the question mark, and you can see range. There's all kinds of fun stuff you learn with OSPF. A stub area, you get into totally stubby. NSSA, you know what that stands for? Not so stubby area. Seriously, that's an acronym for not so stubby area. That's all in the CCNP, and they kept it there for good reason. It's a lot of information. Okay, so area 10 range 10 dot. Well, let's hit the question mark. 10.10. Notice it says IP addresses to match. It's saying what do you want to match, and then summarize. And then it says what's the mask for the address. So 255.255.0.0. Enter. Okay, right? So let's hang on. Let's do a show IP route on router 2, and let's just see if anything has changed here. So I've got okay. What? It's not working. I've seen all these more specific routes right here. Now, oh, wait a sec. What's this? 10.10.0.0/16 is a summary null 0. I don't get it. What's going on? Okay, so here's what's happening. Router 2 is connected. Hang on, let me just clear all this off. Router 2 is connected to Area 10, and as a link state protocol, the requirements is that it now knows everything about Area 10. That's my exclamation. It knows everything about that area, and it's also connected to Area 0. It knows everything about Area 0 because it's plugged in there. Now, the rule is, OSPF rule is, you cannot do summarization in a single area. That's why we're here right now doing a multi-area configuration so that we can do summarization, right? So that we can make things optimal for our configuration. So the problem is, since I can't hide anything in Area 10, then Router 2 is going to see all those more specific routes. But what's up with this? Well, when you implement a summary route, it actually creates that route. It says, okay, I've got a new route. You typed it in 10.10.0.0/16 goes to null 0. All right, who has a guess? What is null 0? Yes, you in the back. The garbage can. That's right. It is the garbage can. Anything going to this will absolutely go into the garbage can and be dropped. Now, hold the phone. So you're saying anything that the router 2 receives that's destined for the 10, anything going to the 10.10 network is going to get dropped. Yes. That's exactly okay, that's broken. Well, now remember, the number one rule of routing. Number one rule, and if you learn nothing else from anything I ever tell you about routing, this is your number one rule to remember. The more specific the subnet mask is, the better the route. I'm looking here. These are also routes to the 10.10.0. something or 10.10. It looks like we've got 3.2. These are also routes to the 10.10 network. Notice there's something. Now these are loopback interfaces, so it's weird to see a /32, but it's just one address, but that is way more. Which is stronger, 32 or 16? 32. It's stronger. It's more specific. So when this receives a packet, for the let's just say 10.10.3.1, it's going to look and it's going to be like, let's look right there, 10.10.3.1. I see it. I'm going to send it. No, whoa, wait a sec. We got a match here. Well, this one's more specific. I'm going to use that. Then you might say, well, then what's the point of this? It keeps loops from happening. What do most routers have that help them reach the internet? A default route, right? So for example, if this guy, let's just say for grins, I throw it in there, it's got a connection to the internet and it has a default route that says match anything and send it to the internet. Well, if somebody sent a bogus packet, like a packet ended up at router 2 that was destined for 10.10.63.59, well, we put in a summary route that told our network that router 2 knows about everything starting with 10.10. So router 2 would be like, oh, I'm supposed to know about that. That's me. So the problem is then it would say, okay, well, if this wasn't here, it would look at its routing table and go, well, but I don't really know about 10.10.63.59. I don't know where that is. So it would say, okay, well, I'll just send that out to the internet. So yikes, now you're sending private communication out to the internet. So this is here as a stopgap. And so what it does is it makes sure that you're having a more specific route in the routing table for this summary that you just introduced. Now, let's look at router 1. Bet your router 1 looks better. Router 1, now notice this was the before. It's like a weight loss commercial. Before, we've got all these 10, 10, 10. So let's do a show IP route. After. And notice all of those 10, 10 specificities, make up a word, are gone. And they're now replaced with this summary route 10, 10. It doesn't, I mean, there's nothing special about that summary. It looks just like a normal route, but it's blocked and summed up all of those routes. Okay, let's do it again. That was too fun, but too fast. I'm going to router 3. Router 3, our other area border router, right? And let's keep router 1 in the perspective because it's the one where we really see these optimizations. I'm going to go on router 3, and I'll do router OSPF 1, and I'm going to do area, what was it? Area 20, right? Yep, right here. Area 20. So bring that back up. Area 20. Range. Hang on, I want router 1 still in our view. I feel like I'm a magician. Watch me do this magic trick. Area 20 range 10.20.0.0 with a mask of 255.255.0.0. Enter. Now when I go back, I'll do a show IP route. It's instantaneous. I now should see a route. Hang on, got some message in there goofing us up. Right there. I see now a route on router 3, this summary going to null 0, same concept as router 1. Now, magician, watch me pull this rabbit out of my hat, hit the spacebar, and bam, look at that. 8 routes summarized down to 2. That is the power of multi-area OSPF. Is now we have summarized this entire area 20. All those routes are summarized as they pass into area 0, and keep summarized as it goes into area 10. So that's where the optimization comes in. Now I got to show you one more thing. Router 1, I want to get set up as an autonomous system boundary router. Now, the way I'm going to do that is a little bit weird, similar to creating all these loopback interfaces over here to pretend like I have networks. I'm going to create a bunch of static routes over here. As a matter of fact, I already have a bunch of static routes on router 1 pointing to these mystery, actually make-believe networks somewhere out here in the great abyss of white space. Now, what I'm going to do is I'm going to take these static routes, and the way that you build an ASBR is through a process called redistribution. Warning, I'm heavily into CCNP material at this point. This is just, if you really are like, man, this is awesome, I want to keep watching, you can. If you're like, my brain is full, stop now. So on the router 1, I'm going to do redistribution and send these static routes into the system. And now that automatically becomes an autonomous system boundary router because it's sending routes from external, from outside. And you'll see why I keep emphasizing external. That's the kind of label those routes get. So welcome back, router 1. I have the show IP route showing right here in the tab. Now, notice all these static routes, I actually have them pointing to null 0. Here, I'll show you how I did it. Show IP route, show run, include IP route. And you'll see all I did was go into global and type these static route commands and point them to null 0. But nobody cares that they don't go anywhere. They look like real routes. They feel like real routes. They'll just drop packets if you actually try and send something to them. The way I'm going to do this and go into router OSPF 1, right? And I'm going to do redistribute static. So I'm saying take static routes and send them into OSPF. Right, redistribute static, and I'm going to say, okay, well, I want to consider subnets, all the subnets, because otherwise it's weird. OSPF will summarize these all to 172.16 because it's a Class B network. So I want to do all the subnets as well, not just do the one big, it's called classful network. And I want to specify a metric. Whenever you do redistribution, it doesn't know how much cost to assign these guys. It doesn't know, well, remember OSPF's cost formula, cost equals 100 divided by bandwidth in megabits per second. Well, these guys don't really have a cost because I'm just throwing them in there. So it'd say, well, what cost do you want to give them? And I'll say, well, let's start them off with a metric. You call this a seed metric, by the way. Let's just give them 100. You're like, where'd you get that? Made it up. That's all you really do when you do redistribution is you make up whatever metric you want to give them. So now, wait, hang on. That was a moment of silence because we just created an ASBR. Yay! So now I can go over to router 2. Right there. Show IP route. Right? So hang on. These guys should all be summarized at this point, right? And they will be. But now, look at that. Well, there's my summary. But look up here. Look at all these routes. These are all, notice E2. Now, I'm not even going to go there. You're like, What's E2? It's external. There's actually two kinds of external routes. E1 does not increment its metric, and E2. Wait, no, I got it backward. E2 does not increment its metric. E1 does, but I'm just going to leave. We have created an ASBR. Yeah. See, this is why I'm on slippery ice when I start getting in these topics, because you can go deep really quick. But that is how you can actually send outside routes into the system and create an ASBR. Come on, one more thing on this. The way that we can actually summarize those, because I'm looking at them, I'm like, I want those summarized a little better. I can actually go into router 1, who is the ASBR, the only other kind of router in OSPF that can summarize. The ABRs can do it, these guys, and the ASBR, but we use a totally different command. Summary address. Why a different command? Well, because these don't belong to an area. They're external. They're outside the system. So I use the summary address command, and I just type in, well, what summary at 172.16.0. Same concept as the area range command. It's just now applying to outside systems. That's it. So now I've summarized all of those routes. Shoot. Right there. Summary route to all of those routes. I bet you I was so fast I caught it before it even eliminated that one from the table. I was ninja speed. So right there, all of those has been consolidated down to just that class B network. Awesome. Okay. Can I show you just a couple more things? I did say this was implementing, but I also said it was verifying. So there's a few verification commands that I want to include. Hang on, let me just clean this all off. Boom. All right. So the commands. Hang on, let's just bring up router 4. First thing I want to show you is a debug of the neighbor formation process. It's like National Geographic. Let's watch these neighbors form. So I'm going to go on to router 4. I'm going to do a debug command, debug IP OSPF adjacency. And now it's kind of that's what it stands for, but the actual command is ADJ. That's the full command that's there. So I'm going to hit enter on that. So it's saying, show me things that apply to my adjacent devices. Okay. So now I'm going to do a clear IP OSPF neighbors. Or wait, no, process. Which will clear all the OSPF neighbors. And we're going to watch this neighbor relationship form. This, I hope, will solidify some of what we saw in the nugget on OSPF concepts on that neighbor formation process. Okay, so it's gonna and then over there and that. Okay, so what it did is it first off took them all down. It says, okay, all these are now changed to a state of down. We cleared the neighbor. The neighbor is down. Got to stop this scrolling. So all of them came up. Now notice right here, it reports that we just went into two-way communication. Like I just started forming, this is from router 4's perspective, I just started forming a neighbor relationship over here with router 3. So then notice this. It's kind of starting like, oh, it's real. The DBD, it's like, okay, I just sent a DBD over to neighbor 3. So what does that tell us? That told us that router 4 was the master. Remember that master slave? So router 4 ended up getting elected as the master because it has the higher router ID. And then so it sent his first, then it received it, and it says, okay, I've got my first DBD, and I'm not a slave. It's like a proclamation. I am not a slave. So I received the DBD. It says, okay, the negotiation done. We are the master. Yeah, they're just kind of doing their DBD dance with each other. Then notice it says exchange done. Remember the states that I talked about in the neighbor formation process? You go from two-way to exchange. That's where you're exchanging the DBDs. Then it moves into loading, and that's where it starts sending link state requests, like LSRs. I didn't know about this network. It goes, okay, there's an LSU. There's my link state update coming from them. So it's going back and forth. Now, there's not much to tell in this little process, so it's receiving them. Now notice it says over here, this is a valuable thing to know. So these guys, remember this process? So let me document it here on the board. We've got our hello, right? That's the first thing. Then they're like, okay, I'm the master. You get my DBD. DBD, horrible writing. DBD. Go back. Then they start doing the loading, right? He says, okay, I didn't hear about this packet. That's a link state request. Or I didn't hear about this network. So he's asking for some of the networks that he didn't know about. This guy sends a link state update, right? We knew that, but here's something you may not have known. Link state update is an envelope that actually contains inside of it one or more link state advertisements. I know just when you're like LS'd out, you're like, no more, man. LSA, that's actually the biggest one of them all that you want to know. A link state advertisement represents a network. So every single network, think of them like a baseball trading card, right? Like you've got your Mickey Mantle 1974 rookie card or whatever. So an LSA is like a baseball trading card for a network. So this network over here, like what was that guy? 172.30, 172.30.0.0/24, he gets an LSA trading card. It even has his version, his subnet mask, his stats, like all the key statistics about him. And that goes and gets traded all around the network. Everybody gets that baseball trading card. Well, this LSU contains, in this case, look at this, 8 baseball trading cards. You want to make a bet? I bet you if we counted up all of these networks, we would end up having 8 networks that Router 4 didn't know about. Because that's exactly how many LSAs ended up being sent over to Router 4 that it got all the details for in one LSU packet. So it's pretty efficient when it does that. So then as we scroll down, you can see it then starts saying, okay, well, I'm going to build my router LSA. I'm going to build LSAs for my area. And then it goes ahead and sends them out to Router 3. Now we're synchronized. So that's the process. Very, very, once you know the neighbor process, it's like, that's cool, to be able to look. I mean, how many times do you do a debug and you're like, I have no idea what that means? But now we actually do. Okay, so I'm turning off all the debugs. Other useful show commands we already did. Show IP OSPF neighbor. There's our neighbors. Show IP interface. That's what I'm looking for. Interface. And it shows what interfaces are running OSPF. And biggest thing right here, hello and dead timers. You won't run into this too much in the CCNA, but CCNP you do all the time because you get into some crazy frame relay configurations inside of there. But you see hello and dead timers. If those don't match, remember the neighbor criteria of the hello packet. If those don't match, neighbors don't form. Watch what happens. I'm going to go into router 4 interface 00/0. And I'm going to help. I'm going to do IP OSPF hello timer, hello interval. I'm going to do, let's just say I want 5 seconds. I want to say hello more often so I can detect if that neighbor is dead. Well, as soon as I do that, as soon as I send the next hello, router 3 is going to be like, yeah, you're not valid. I'm not accepting that hello from you. Well, so as a matter, now I'm not seeing the neighbor go down because, let's do a show IP OSPF neighbor, because his time is still ticking. You see what's happening here? Notice all these guys are like, okay, he'll be dead in like 30 seconds, and then they reset themselves. He's like, oh, I'm back up here. But notice this guy, he's ticking down. He's no longer, router 3 is no longer accepting hellos from router 4 because he's like, hey, you don't match me anymore. You've just gone down because now you're an invalid neighbor to me. It's like a made-for-TV drama. You're dead to me, router 4, because the hello timer doesn't match. Now if you're troubleshooting, you're like, what's the deal? My neighbors aren't forming. That's where you can go back and do that debug IP OSPF adjacency. And you can start seeing, okay, well, it looks like we're getting hellos in there. Hang on, let's do a show IP OSPF neighbors from this side. Notice it's just gone. There's nothing there. You'll start seeing hellos and it'll be like, we're not compatible. IP OSPF. Let's just do a packet. Show me everything that you're getting from OSPF, and we can even turn on events. Now we're getting into the deep and nitty-gritty troubleshooting. So you can see I'm sending a hello and it's going out there. Now if we turn debug on this side, we would receive a hello. On this side it would say, oh, sorry, this is incompatible. Oh, there we go. That's what I was waiting for. You all. As I'm doing these packets, it says, okay, we received a hello. Woohoo! A neighbor denied. Why? Mismatched hello parameters. Because in this case, it even spells it out for me. It says the dead timer here is 40 seconds, and I'm seeing over here on this side, well, I shouldn't. It's spelling. I'm like, I don't know what all those fields are at the top of my head. But I know the dead timer is 40. It's trying to say, all of these hello packet values right here don't match what are in mine. It's pointing me right in the right direction. So that allows me to go in there and into serial 0/0, and I'll do no IP OSPF hello interval. Now you might say, well, you're turning. No, I'm just undoing the configuration that I did, which returns it back to default, and now you can see the neighbors come up and they're happy. Wait a second. Hang on. I do know this. I just had to stare at it for a little while. What it's saying is, hey, you mismatched hello parameters. The dead timer for the remote device is 40 seconds. For me, I have a dead timer of 20 seconds because I adjusted mine when somebody adjusted the hello interval. Then right here it says the hello for the remote side is actually once every 10 seconds. My side, C I'm guessing means console, is once every 5 seconds. So it really is spelling out well, it's spelling out in its own special way exactly what is wrong and pointing us in the direction of the timer. Okay, good. So we have seen some good stuff in this nugget. We have seen multi-area configuration. I will say currently, in as I'm recording this right now, CCNA does not test on summarization and ASBR configuration. A lot of the stuff that I showed you, that CCNP stuff, but my thought is they can't stay that way. There's no reason you would go into a multi-area OSPF environment unless you were doing summarization, because that's the whole reason that you did it. So you got to see a lot of bonus information along with some of the verification, some of the troubleshooting commands to tweak, to kind of tweak and make sure everything is working the way it should. I hope this has been informative for you, and I'd like to thank you for viewing.